we've been looking at numbers like root 2, root 3 recently in our channel, and that is the square root of non-perfect squares, root 5, and these are irrational numbers. We have quite a few videos in our channel about these, but today we are interested in plotting these numbers on a number line. So in the introduction videos, we saw that the root 2, the way we arrived at it is by drawing a square of unit side. So each side is 1, and we argued that the diagonal of the square has to exist in real life because squares of unit side obviously exist in real life. So the diagonal has to exist, and by the Pythagoras theorem this diagonal was equal to root 2, the square root of 2. Now we are interested in plotting this distance, this root 2 distance, on a number line somehow. So this is my number. Wait, let me draw a number line. Say that this is my number line, and it goes on in both the directions, and there's my center 0. So I'm interested in plotting root 2. I know that it will be greater than 1 because 1 square is just 1, and I know that it will be less than 2 because the square of 2 is 4. So root 2 has to lie, the square root of 2 has to lie in between these two. So pause the video and think about how we can plot this distance that we have on the diagonal. We don't have it on a number line yet. How we plot this distance on this number line. I hope you have tried. I hope you have thought of something. Well, let me guide you through it now. So say that we draw the square on this number line. That's possible by just a ruler and pencil. So this square, I draw it on a number line. So luckily the side length fits, and we connect these 2 points. We know that this white line represents root 2 distance. So how do I map, or how do I plot this root 2 distance on this number line? So using the tools we already have, using a compass, what I do is I place the center of my compass, the needle part of my compass, on 0, and I measure this distance with my pencil, the pencil part of the compass. So this is my pencil, right? And I measure this distance, and now with the same distance, without changing the length of the compass, without changing the arc of the compass, I cut the number line at wherever the pencil cuts it. So if you want to picture this, so this is, say that this is my compass, this is my compass, this is the needle part, and this is my pencil arm. So I measure this distance and I cut it here. So now I know that this distance is equal to root 2, the square root of 2, right? This distance, which is not very neat, this distance is the square root of 2. So we have successfully plotted square root of 2 on a number line. So now what about the square root of 3 and the further square root of 5, square root of 7? So what do? We already have a square root of 2 in at disposal now. This is the square root of 2 we have. So we know that by using just basic Pythagoras theorem, we know that if we have a rectangle of length square root of 2 and breadth, which I'm calling the height now, square root of just 1, so this length, the length of the diagonal, so this is the rectangle, the length of the diagonal should be equal to the square root of opposite side squared by that plus the adjacent side squared, which turns out to be 2 plus 1, which is square root of 3. So luckily we do have this, and we have root 2 at our disposal. So now what I do, Again, I use the tools I already have. I'll erase off these, and using the same square root of 2 line, I won't erase the line. Yeah, using the same line, I draw a perpendicular, that is a 90-degree line from this square root of 2 line. So I draw this perpendicular line with my scale, or with a protractor if you want. You draw a 90-degree line that measures 1 unit. And what do you do? 1 unit as in 1 inches or 1 centimeter, whatever you're comfortable with. And now this blue line, I know that it's for sure equal to the square root of 3 as calculated here. So now again I have a slanted line which I have to plot in the flat number line. So what I do is I measure this length with my needle. I place my needle here, I place my pencil here, I measure it, and I cut it here somewhere, and it will be still less than 2, because the square root of 4 is equal to 2 and the square root of 1 is equal to 1. So the square root of 3 would be between 1 and 2. Now this blue line, this blue length, would be equal to square root of 3, and so on. If we just go on, we continue this process forever. So this will be the square root of this, another perpendicular line drawn would be of unit, if it's of unit length and this is square root of 3, then you can verify that this diagonal would be equal to 2 units because it's the square root of 4. And if we go on still further, again a perpendicular line from this line of unit length, the diagonal of that rectangle hence drawn would be equal to the square root of 5. And you do get the gist of where this is leading to. You get all the square roots of integers, of natural numbers. So I hope this was useful, and hope you understood. Thank you.